HRS Services has a 25-year history of working with the top 10 UK contractors on projects advising on air tightness from the design stage through the construction phase to the final air test. The objective of this presentation is to share with you a best practice approach to achieving a successful outcome to your building's air test in 7 easy steps. Step 1. Assess the risk. All the issues associated with air tightness can be effectively resolved if the construction team is aware of the risk that the air permeability target poses to the project. Construction projects with an air tightness of 3 or lower should be aware that 50 to 80% of these buildings fail their first and subsequent air tests. Correctly assessing the level of risk enables a contractor to allocate sufficient resources to the issue of air tightness. This is a numbers game. The lower the number, the higher the risk. You must also be aware that some projects that have an aspiration of 1 can manifest themselves as tighter than passive house standard if the building volume to envelope area is right or wrong given how you look at it. Any project that lands on the desk of a pre-construction manager or design manager that is 3 or below is well worth a second look and risk appraisal. If your experience is limited on projects of 5 and below, then you could be venturing into an area of high financial risk to the business. Where does the air permeability figure come from? There is a design aspiration for the building to have an energy and CO2 emission performance. The lower the usage, the more energy efficient the building will be. The more airtight the building, the less energy required to heat and cool the air within it, as it won't be losing air to the outside. Simple. However, now and then the M&E designer overestimates the energy use of the lighting design, and they may have been a little conservative with the operating capacity of the HVAC, and the architect may have uprated some of the insulation in parts of the envelope. The outcome is that the SPEM could be rerun with a less onerous air permeability target, and the building can still achieve its intended deck rating. What does this mean to the main contractor? It means that if you don't achieve the target air tightness score on the day, then there can be room to explore a relaxation of the specification by an SPEM rerun. Step 2. Understanding the risk. We can assess the level of risk through a simple evaluation of the target value 1, 3, 5 and 10, but understanding the risk is particular to each building. First principles. What are we testing? Can we easily define what is to be included or excluded from the test? What defines the primary air seal in the envelope? What is the relationship between the floor to the wall and then from the wall to the roof? How many facade elements define the air seal and what is the relationship between them? Is the air seal component in the construction a concealed material? Where is a project at risk of the air seal being compromised by poor detailing and a loss of continuity? Step 3. Appropriate design. It is obvious to state that a simple building form with a minimalistic facade construction will achieve a better performance in air tightness. Think a composite box warehouse achieving below 3 with ease given a modest standard of workmanship. However, the architectural design doesn't always, if ever, give consideration to the air tightness target for the project, and in some respect that was never on their agenda. The more complex the building form and the number of facade elements will without question increase the risk of failure. HRS Services offer an air tightness consultancy package that begins with a review of the construction drawings that is a good starting point for bringing the architectural practice and the subcontractors to the table to discuss and review the air seal details at an early stage in the design process. Step 4. Subcontractor procurement and supply chain management. The main contractor is reliant on the envelope subcontractors and the building element components to provide the air tightness performance for the project. An audit of the subcontractor and the components and materials in the supply chain is recommended to ensure they meet the project's needs. A project with an onerous air tightness target and a high-risk design brief must be explicit with their subcontractors and their facade component suppliers about the performance criteria for the building. This must be highlighted in subcontract and specification documents in order to reflect the risk that each package carries in providing the primary air seal for the project. As much as possible, all by others details need to be apportioned between subcontractors to maintain the continuity of the primary or secondary air seal between elements and components. A few simple pointers. Use windows and doors with an assessed air permeability classification to BS EN 12426, 12207 and BS 6375. Use appropriate details for composite panels. Paint block work without manufacturer's air leakage data. Identify and treat high-risk junctions. Step 5. Build for air tightness. All good drawn details can be easily compromised by poor realisation during the building phase due to buildability and sequencing. Contractors must insist on best practice by their subcontractors on high-risk projects. In some cases, this may require a traffic light system of inspection of air seal constructions and materials, especially if these are to be concealed by further works. Step 6. Coordinate with M&E. The heavier the M&E provision for a building, the more complex the air test preparations and the more opportunities for unintended air leakage through unsealed ducts, pipe and electrical cable penetrations. The M&E contractor is potentially the biggest risk to your ability to pass the air test first time. The final stage commissioning process needs to be programmed so that it doesn't conflict with the day of the air test. Step 7. Prior preparation. Remember, the air test is undertaken to measure the performance of the building envelope. It is as much a measure of how well you temporarily seal the natural ventilation and HVAC systems. This requires a good understanding of the installed systems in your building and coordinating with the M&E contractor as to the most effective method of sealing the system either locally or centrally. So, ensure you do the following. To recap, the 7 steps to passing your air test first time. Assess the risk. Understand the risk. Appropriate design. Subcontractor procurement and supply chain management. Build for air tightness. Coordinate with M&E. Prior preparation. If you have any further questions, please contact us at HRS Services.